Morning to all. Okay, previous class we understood basics of C programming language. We started with the very basics and we understood few things. From today and for the next class is the lab session class. Okay, I think probably tomorrow I'll be giving you the first lab program, which is based on the arrays. Okay, which you are already familiar with, and including me, the other faculty members, the faculties who are handling for the other section, they have decided to cover exclusively on the arrays, structures, and the pointers. Since the classes for the previous semester were online, I don't know how you people know about the arrays, structures, and pointers. So since these concepts are very much essential for the data structures, so we have decided to cover these topics in much details, and then we'll be continuing with the data structures. Okay, let me continue. And yesterday I had stopped. We had started discussing the pointers. Let me continue from there, and again I'll be focusing more on the array structures and pointers. Okay, I'm sharing my screen. All of you can see my screen?
Yes, sir.
Yes, sir.
Okay. Okay. So this is what we understood the structures and few examples on that, even arrays also we understood, and few programs also, the example programs, and all these programs were also explained to you people. Okay. Type def you understood. See, if you want to create an alias name to any of the data type in C programming language, you can use the type def. So type definition and create the alias name to the data types, and you can have your own name for the data types. Okay, and this is very much essential here in the data structures, because if you use type def definitions, you can avoid writing long structure names. Okay, so and we will be using this here, and then we had started discussing pointers in the previous classes itself. Pointers, as I mentioned, is a special variable that is used to store the address of another variable. So now how do you make it as a pointer? By using the operator asterisk. Okay. Say for example, I need to create an integer pointer. Now I'll be writing it as int star a. Now a is a pointer variable, and what it can store is the address of another variable. Okay, it points to some other variable. So when I say address, it is holding the address of some other variable. What does it do? It points to the other variable. Okay, and one important thing here is, now the pointer stores the address of another variable, and addresses are by default what? Integers. They are integers. So you cannot have the floating point address. Hence, pointer stores an integer. Say for example, if I say int star a, no doubt it is an integer pointer, and it stores the address of another integer variable. But what is that value? Well, the address is an integer data. Okay, and size of the pointer is equal to size of the integer always, because since I'm telling the pointer stores the integer data, because all addresses are integers. Now what will be the size of the pointer? Size of the pointer is always equal to the size of the integer. Okay. Now it depends on the processor. So how many bit processor is your system? Say for example, if yours is a 16-bit processor, so then the size of the pointer will be 2 bytes or 16 bits. And similarly, if your machine, the laptop or the desktop what you are using is a 32-bit machine, then the size of the integer will be 4 bytes and the size of the pointer is also 4 bytes. And a pointer that stores the address of integer variable is called integer pointer, and similarly the pointer that stores the address of another character variable, we call it as a character pointer, and a pointer that stores the address of another floating point variable is called as a float pointer, something like this. And I have the example also written here, int star IP. Okay, so this is the pointer now. With what pointer? It's an integer pointer, and it can hold the address of another integer variable. And remember, so the addresses are always the integers. Okay, and even last class I think I mentioned so the universal pointer also. So you can have universal pointer. Say instead of saying it as star int IP, int star IP. So if you just make it as void star IP, then it becomes void star IP. So then this is an universal pointer. So that means you can go for assigning the addresses of anything to this. Now when I write like this, I can only go for assigning the address of what? This can only store the address of another integer variable, but this IP here, it can store the address of anything. Either it can go for storing the address of a character or a float or integer, etc. Something like this. I hope you understood till here. So is the concept of universal pointer clear?
Yes, sir.
Yes, sir.
Yeah. Next, again continuing with the pointers. So the pointers that store the addresses of double, character, float are called double pointers, character pointers, and floating pointers respectively. So in the previous slide, so we understood it with respect to the integer pointer. Now here similarly you can have the pointers created to hold the addresses of the double value, addresses of double variable, floating point variable, and the character variable also. Now how to create a pointer to the character variable? So something like this, character star CP. Now this can hold only the address of another character variable, and float star FP. So this is the float pointer, and this can hold the address of another float variable. So and double DP, so this can hold the address of another double variable. Now this is how you can create the pointers of various types. Now how do you assign the values to the pointers? So like this, as I already told, so pointer stores the address of another variable. Now this is how I can do it. So int star IP is equal to ampersand A, assuming A is an int already declared. Okay, so it must be what you are writing here, it must be an integer variable, and by this ampersand, because what you can assign to a pointer is the address of another variable. Okay, this is how you got to do it. Now so ampersand, it means what? Address of A. Now you are assigning address of A to this IP. Now this is holding address of A, or in other words I can say IP is pointing to the memory location A. So A is a memory location, and it has some content, so it's pointing to this. Say for example A value is 10. Now what IP is doing, it's pointing to this. A is the name given to this particular memory location, and the value at that memory location is 10. Say let us assume the address is 1000. Now what you'll find in IP is holding this 1000, nothing but, so now the IP is pointing to this particular memory location. So using IP I can access this particular memory region. Okay. Now we have some examples on the pointers here. I have a normal integer variable int A, and then we are assigning the value also to it. A is equal to 10. So then I have int star IP, the pointer declared with the name IP. Now what we are doing, IP is equal to ampersand A. I am storing the address of A to IP. Say 1000. You can assume the address of the variable A as 1000, and what gets assigned to IP is 1000. Now if you just write only IP, what it fetches you is 1000, because what is stored, what it is storing, address of another variable. Okay, it fetches you 1000. Okay, if you write it as star IP, it gives the value of that address. Okay, now only IP will give you the address, only the name of the pointer will give you the address. If you're using the name of the pointer with the dereferencing operator star, it will give you the value. So hence the star, the operator which we have written here is called as the dereferencing operator. You can always get the value from the pointer by using the dereferencing operator. Okay, is it clear?
Yes, sir.
Yeah.
Yes, sir.
Next one. So next, I hope you people understood with the concepts of pointers. Again, we'll be discussing it in more detail with more examples. Call by value, and this is important, and I hope all of you have done this call by value and call by reference even in previous semester. So calling a function with parameters passed as values is nothing but the call by value. Now you are passing the actual values, okay, then it is called by what value? You are making a call to the function by passing the actual values. So I have the example here. Int a is equal to 10, variable a initialized with the 10, then we are making a call to fun, and what we are passing the parameter is a. Now here, when in the calling, or in the declaration, it is called as the actual parameter. Now a is the actual parameter. Now here the function definition, so what is this called as? So what is this a? Here,
parameter.
yeah. So this is actual parameter, and in the definition, so this a is the formal parameter. Okay, formal parameter, or else you can also call it as the formal argument. Okay, next, and the definition goes here. Okay, now what you are doing here, you're passing. So it's a normal variable, integer variable assigned with the value 10, and you're passing this value directly. Okay, this is passed by value. So function a is a call by value. So why call by value? Because you're directly passing the value. Any modification done in this function is local to it and will not be affected outside the function. Okay. Now what happens when you're passing? Say for example, so the a I am passing, this actual parameter a gets copied to this formal parameter a. So the name, we have retained the same thing here. Okay, name is same. See, is it mandatory to have the same name? No, you can give any name. Say for example, I don't want to use a here, let me use x. Not an issue. And what I do, the value here which is available at a, actual parameter, gets copied to the formal parameter x. And whatever the update you do within this function, it is applicable only to what? This formal parameter, and it's no way going to affect the actual parameter. Is it clear?
Yes, sir.
Yeah. Now call by reference. Now what you do? So call by reference is nothing but calling a function by passing a pointer as the parameter. Instead of directly passing the value, we go for passing the pointers. Do you know what is a pointer right now? So we pass the pointers. Or in other words, So instead of passing the value, we pass the address of variable. Okay, address of a variable is passed instead of the variable. Now here we have the example. We pass the address. Now I have int a is equal to 1. So the value of a is initialized to 1, or in other words you can say it as a is assigned with the value 1, or 1 is assigned to a, anything. Okay, this is the assignment operator. Now fun ampersand a. Now what I am passing now is not the value 1, instead I am passing the address of the variable a. So value is 1, say this is the name given to some memory location and the address of that particular memory location is 1000. So it is 1000. Now what you are passing in function call is 1000 and not the value. It is the address what you are passing. Now here address I am passing, but I don't want the address here. I just want its value. Now what happens now, since I am passing the address, now here I am using the pointer. So when it is call by reference, so in the formal parameter you should have the pointer. Okay. Now if I just remove this dereferencing operator, now what will happen? So x will not get the value, instead it will get the address. In case if I want to get the value, then I have to make use of the dereferencing operator star, because I've told you in the previous slide that when you use only the pointer name, it gives you the address. With the dereferencing operator, it gives you the what? Value. Now address gets copied to this, but star x says what? Star x says the value at that. Now you can use here inside the definition, and you can perform the computation. So now what happens? So both will be pointing to the same, since the address is same here. So this a address was 1000, and here also what address gets copied? 1000. So there even the x is also pointing to the same memory location. Now whatever the update you do here, say for example a value is 1, so inside the definition I make it as a is equal to a plus 1. So a becomes 2, correct, right? X is x, using x I'll increment it. Now it gets reflected ultimately where? To this, because x is also pointing to this particular memory location. So but this will not happen here. Okay, this is not going to happen in the call by value, because this is a totally different variable, because the entire value gets copied to this, and any update you do, it will remain in what? A. And you have something called as local scope and global scope also. So the variables have something called as local scope. If you declare any variable inside the function, the scope of that variable is limited only to that function. Outside that function you cannot access. In case if you want to make use of a variable throughout the program, then you got to declare it in the global scope. So before the main, if you do that, if you declare it, so the scope of the variable remains throughout the program, and anywhere you can use it. So next we have an example of the call by value. So same example which I was discussing, only thing I used to write there using the pen. Now I have the example in the form of the program. Okay, so int a is equal to 10. I am assigning the value 10 to a. Now printf this percentage d a, I am just trying to print the value of the a as it is. Now what it should print? It should print out me a is equal to 10, and then we are making a call to fun a. So this is call by value. Okay, I am calling the function fun by passing the variable. Now it comes here. Now what happens? So the value which is available at a, the formal actual parameter gets copied to the formal parameter x. It is copied to x. Now I am printing x. Yes, no doubt x value is out how much? 10. And then I am incrementing x. Then calling printf again. So this incremented value is reflected only in the memory location. Now you have two memory locations now. A is one memory location, x is another memory location. The original content of a was 10, and when you make a call, when you made a call to fun by passing a, so x was also made as 10, and this memory location you are updating inside the function. So from 10 to 11, but this value remains the same. Okay, that is what call by value. Okay. Is this clear till here?
Yes, sir.
Yes, sir.
Okay. Now the same thing so pictorially represented along with the addresses. So this is the name of the variable, or in the words you can say it is the name given to some memory location. This rectangle box, what you are seeing is the memory location, and the name given to this memory location is 10, and what is the value which is present at that memory location is 10. And what is this 1000 is? Address of this memory location. So every memory location will have the addresses. I am assuming the address of this particular memory location is 1000, and the name, because always I cannot remember the memory locations by the addresses. I have to assign some names, correct? No? So what is the name assigned to this particular memory location? A. I can access this particular memory location in two ways. So either by using the address or by using the variable name, because variable name is the name which is given to this particular memory location. Say when I call function say fun A, so what's happening? So A is getting copied to X. So there is one more memory location with the name X, and the value which is here gets copied to this memory location X. And let us assume the address of this particular memory location is 1002. Now why this is 1000 and this is 1002? So because I can assume it as a 16-bit machine. So it's a 16-bit machine or a 16-bit processor. The size of the integer is 2. So since this is an integer variable, so 10 is an integer, how many bytes it will occupy? 1000, address 1000, and it will continue till 1001. And we have this memory location X starting from 1002. Okay. Now what we are doing in the definition, we are doing X plus plus. So it is only updated in this memory location. We are not doing A plus plus. It gets updated here. X 11, 10 will become 11. And so after this function executes, okay, this function executes, the control is written back. So we have written void, that means just as not returning any value, so but it is returning control back always. So the control goes back, and the statement which is following from where the function fun was called will be executed. Okay. Now before the control jams here, the address of this statement, so this printf statement will be pushed onto the stack. So what is that stack called as? RA stack, return address stack. So the address of this statement is written here. Okay. When this function executes and when the control is returning, what it will do? It will check what's there on top of the return address stack. So this is the address of what? This statement. It jumps back and performs the execution of this and prints a value as what? 10 itself, because the memory location A is not updated. Only the memory location X is updated. Okay. So this is the diagram which is pictorially conveying the same thing what I told you in the previous program. Now similarly, call by reference. Okay. Now int A is equal to 10, same thing again, but we are passing the address now, and then A is equal to 10. So I am just printing the value of A again. It says me 10, and then we are calling the fun by passing the address of A. Okay. Now before the control jumps here, what will happen? Address of this printf statement will be saved onto the RA stack, return address stack. So address is written here. After writing the address of this statement, here say let me assume address of this statement is say 4000. So in the memory location, this particular instruction is present at address 4000. What will be written here is 4000. So 4000 will be written, and then the program counter. I hope all of you know what is a program counter is. Yes? Hello?
Yes, sir.
Yeah, you know PC? Program counter. Program counter is a register which guides the CPU which instruction it should execute next. It's a register and it holds the address of the next instruction to be executed. Okay. Now when the function you're calling, the address, the next instruction that needs to be executed is what? This printf. After this fun is called, this is the one that should be executed next. Now what PC will hold? Address of this printf statement. So PC will be assigned with address of this printf statement, and the address of the printf statement that is following fun will be written to the RA. And we had here the control jumps here, so performs the execution of all these statements. And before that, now address I am passing. Now what X gets is value at that particular address. So int star X, it's a pointer, and then printf x I'm doing. So 10 it is printing, and then I'm incrementing x, and then it becomes 11. But this memory location A remains sorry. So yeah, so x is 11 and this is printed. And next what will happen, once the function is executed, the control is written back. So the control is ultimately x and A. So this is A, memory location A, and x is also, what x is holding is, say if I assume the address of this particular memory location is 1000, x is holding 1000. In other words, x is in turn pointing to this memory location. Now when I update x, it is nothing but it is getting updated here. Okay, x value is 11, and when the control returns back, so print A, it should print the A value also as 11. Okay, so clear? Yeah.
So, could you explain how in the starting void main function part, how a is equals to 10 has incremented to a is equals to 11 after you call the function?
After what? Speak louder, little louder.
Yeah, sir. After you, so in the first statement you declare the variable int a is equals to 10, right? Then
Yes.
after you, so the value of a is 10 over there. But after you call the reference function, the function of the a, the a values become 11. How did that happen, sir? How did the increment in a's value happen?
Yeah, this is what. See, x is, it's something like this. Let me clear the annotations. I'll write from the beginning. Okay. Yeah, up to now, I have A is the memory location. Now, what is stored here? 10. Correct, no? Hello? Able to hear me?
Yeah.
Yeah.
Yes, sir.
Now, when I say print percentage %DA, what it should print? 10.
Is, yeah, 10.
10 it will print. I'll write here. 10 gets printed. Next, what you're doing, so you're calling this function fun ampersand a. Say address of this, let me say 1000. This is the address of this memory location, and value at that memory location is how much? 10.
10.
Now you're calling this. Now what you're passing? So this address you're passing in star a will be how much? So x is another memory location. But what it is holding? Is it holding 10 or 1000?
Holding 1000.
1000.
Yeah.
It is holding 1000. The value at this particular memory location x is how much? 1000. Now what it means? It is pointing to this memory location. Since it is holding the address of this memory location, so it is pointing to this. Got my point?
Yes, sir.
Yeah. Now I am saying print x before incrementing. Correct? No? Print x. How much it should print?
10.
10. Because this will not get printed. What gets printed is what? 10.
Value of.
Yeah.
Yeah.
No, I think star was required here. Okay. Now this is 10 gets printed. And next what you are doing?
Incrementing.
Incrementing. Star x plus plus. Now how much it will become? 11. Where? Here. But this address is what?
Oh.
Same. Got the point?
Yeah, correct.
Now you are saying print x. Now either you say print x or print a, it should print you what?
11.
Yeah. So star x 11, and here also where? So sorry, stars are missing. The dereferencing operator star is missing. Got the point? Star x,
Yes, sir.
star x plus plus, and star x. Now when the control returns back and you say print a, how much it should print? Whether print star x or print a, it should print you 11. Okay.
Thank you.
Yeah. So now this is so same pictorially. See, a and x are referring to the same memory location. That is what I showed you here. So a and x. X is a different memory location, but it is holding the address of this memory location. So they are referring to the same location. So the value will be overwritten. So when you update it using x, so it gets reflected in a. Okay, so this is what. Now conclusion with respect to the call by value and call by reference. So copying value of variable in another variable. So any change made in the copy will not affect the original location. Now in call by value, what you're basically doing is copying the value which is stored at one variable to another variable. You completely copy it, and after copying, if you do any changes to one memory location, it will not get reflected in the other memory location. It will not affect the original location, or it will not affect the location from where you copied it. So if you're doing the same by call by reference, creating a link, so what it will do, it will create a link to the original location. So that is what happened here. So when call by reference, so this creates a link to the original memory location. So there is a link. Now next, either you update this, or you try to print using x or a, it should print out you the same thing. Both of them are pointing to the same thing. So creating a link for the parameter to the original location. Since the address is same, changes to the parameter will refer to the original location and the value will be overwritten. Okay, so this is as far as the pointers and the call by value and call by reference is concerned. So I'll just go to the another PPT now. So discard annotations. Okay. So we'll have a complete and thorough discussion on the arrays, because this is important. So in the previous class, I've already told you about the arrays, but this will be a more detailed discussion with respect to the arrays. Okay. All of you can see this programming in C, and the topic is arrays.
Yes, sir.
Yeah. Now, I think first few slides will be a kind of revision slides for you people, because I've told them already in the previous class. So arrays definition, collection of data that holds fixed number of values of the same type. Okay. So, and this is also important. So what they hold, fixed number of values of the same type or the similar, homogeneous collection this is. The size and the type of the arrays cannot be changed after its declaration. That means, say once I say int a of 10, after its declaration, and when you are executing, when you are running the program, is it possible for you to change the type and the size of the array? It is not at all possible. Okay. Say for example, if you want to store marks of 100 students, you can create an array for it, something like this. Say the number of students from 100 increases to 150. So it's not possible for you to dynamically change the size of the array. What you have to do is, you have to again stop running the program, go to the program and increase the size of the array up to 150. So that means, this memory what you are allocating using arrays is only a static allocation, and this memory which you allocate statically at the time of compilation cannot be changed during the execution time, or cannot be increased during the execution time. So some examples where the concept of array can be used. So that is, you should know where we use the arrays. So list of temperatures recorded every hour in a day, or a month, or a year. Say I want to store the list of temperatures recorded every year. Say for example, per day, every hour I need to record the temperature. So for 24 hours, so I can have an array of size 24. Or a month, say I want to record the temperatures every hour for a month, then 24 into 30, I should create an array of that size. Now I want to record the temperature for every hour and for the complete year, then I have to find out, 24 into 30 into 12 I have to do, and I have to create an array of that size. and list of employees in an organization. So I want to store the all names of all the employees in an organization. Then again I can go for creating what the character arrays and list of products and their costs sold at stores. So these are few examples where you can use the arrays for storing the information. Now how do we declare an array in C? So like this. So you have the data type, you got to specify the type for the array. Even for the arrays you got to specify the type, so name and then the size. So this is the syntax. So and the example is here. So float mark 5. Okay. So this creates a floating point array of size 5. So here we declare an array mark of floating point and size is 5, and that is that it holds 5 floating point values. That means you can go for storing 5 marks using this array. Elements of an array and how to access them. Okay. You can access the elements of an array by using the indices. That is what indexes. That is what I told even in the previous class. Suppose you declare an array mark as above. So in the previous slide. So the first element is this mark of 0. This is the 0th index. You have the first marks stored at the 0th index, and if you want to access it, you can access it like this mark 0. And the second element can be accessed using mark 1. And similarly the third element can be accessed using mark of 2 and so on. And there are few key points to remember with respect to the arrays. Arrays always by default have 0 as the first index and not 1. So you got to remember this. So arrays index will always start with 0. So if you don't want to start with 0, then you have to explicitly make array take the index as what? 1. But implicitly arrays will always take the index value, default index value as 0. But any point of time if you are not interested in starting the array index value from 0, then explicitly you got to tell array that start using your own index as the start value. So in this example mark of 0, that is the default index value is 0, and where the first marks or the first element of the array is stored. And the other thing is, if the size of an array is n, to access the last element, now what is that you have to do is n minus 1. Okay. So the number of elements, n is the number of elements in the array, and how do you access the last element? So n minus 1 gives you the index. Since we are assuming the array index starts, by default it starts from 0, the index of the last element would be n minus 1. Okay. So for the previous example, mark of 5 we had taken, and we have the last element of this array stored at mark of 4. Okay. Suppose the starting address of mark 0 is this 2120. Then the next address would be 2124. Okay. Now you can tell by looking into these addresses. Say I am saying you can access the first element of the array by using mark of 0, 0th index. Now if I assume the address of this particular array, the starting address of this particular array is 2120, what will be the address of the next element in the array? So they are stored sequentially. So 2124. Now by looking into this address range, you can tell how many bit processor it is. So it is this is float, right? Yeah. So the size of float is what? How many bytes? 4 bytes. Size of float is 4 bytes. So 2120 is the starting address, 2120, 2121, 2122, 2123. So you have the first element stored. It is occupying these 4 bytes. And the second element is starting from 2124. And the third element starting address would be 2128 and so on. Because the size of the float is how many bytes? 4 bytes. And the size of the double is 8 bytes. And size of the character is 1 byte. Now how to initialize an array? Now there are two ways of initializing an array. You can initialize the array during declaration, and you can initialize the array during runtime. Okay. Now first we will try to understand how to initialize an array during declaration. So this is how you can initialize. So int markup 5 and something like this is equal to open the curly braces, write the elements of the array, close the curly braces, and end the semicolon. Now you have this first element 9 stored at markup 0. You can observe this. So at markup 0, at the index value of this array 0, you have 9 stored. At index value of this array 1, you have 4 stored. At the index value of this array 2, you have 6 stored. At the index value of 3, you have 3 stored, like this. So this is, so since I have taken size 5, I can assign 5 elements to this array. Now there is another method of initializing the array during declaration. This is how you can do it. Size is not specified. Okay. Now for this initialization, even if I put one extra element, say comma 4, it will not accept it. It will not accept it because size of limited it to 5. But here, since I have not specified 9, 4, 6, 3, 5, 4 also, if you take it will accept it. Next, important thing to remember when working with C arrays. Suppose you declare an array of 10 elements, let's say this int test array of 10. You can use the array members from this test array of 0 to 9. So because you have the elements stored from 0 to 9. In case if you try to use test array of 10, okay, so it does not valid, or test array of 11, test array of 12. So all these things are outside the boundary of this array. Now if I declare an array something like this, test array, the lower index is 0 and the higher index is 9, and accidentally, knowingly or unknowingly, if you are writing an index value which is outside the bound of this array, so then the compiler generates an error message. Okay. So now types of arrays again. So in the previous class we understood only the basics of the arrays. What is an array? All these things. But so we are discussing it in more depth now because this is required. Now one dimension array, 2 dimension array, and multi-dimensional arrays also. Okay. So one dimension array. So what we discussed in the previous examples and all, they are all one dimensional arrays. So a list of item can be given one variable name using only one subscript. So this is the only one subscript. And such a variable is called a single subscripted variable or a single dimensional array. So how many subscripts you are giving? There is one name and there is how many subscript? One subscript. So float item 50, int group 10, character name 10. So these are all the examples for the one dimensional array. Okay. Now we have here again another example. So int 5, how do we declare a one dimensional array? Same thing, int number of 5, and this is the resort spaces. When I say number of 5, the lower index is 0 by default and the higher index is the size minus 1, that is 4. And storing values after initialization. So at this particular index we have 35 stored, at this particular index we have 20 stored, at this particular index we have 40 stored. So like this, it goes like this. Now initialization of one dimensional array. Now you understood what is one dimensional array and you are familiar with that. So that's called as one dimensional array because an array name which has only one subscript is called as a one dimensional array, and it can be initialized at 2 stages. A one dimensional array can be initialized at the compile time, and you can also go for initializing the 1D array at the runtime. So compile time initialization. Okay. How do I initialize the one dimensional array at the compile time? This is how we do it. So this is even in the previous slide I showed you. So you got to declare the type of the array, name of the array, and since it is one dimensional array, you should have only one subscript is equal to list of values separated by commas. So the values in the list are separated by commas like this. This is what I showed you. Okay, this is how you can initialize the 1D array at the time of compilation, or this is also called as initialization at the time of declaration. Okay. Now, how to initialize an array at the time of execution or runtime initialization of the array? So, runtime initialization of the array can be always done by using a for loop and a scanf statement. So, this is how you can do it. Now, say the array x, what I am using here is of size 10. I want to initialize all the elements of my array x during runtime. Now, how do I do that? Now, I have to run a for loop for I is equal to 0, I less than 10. So, now this will go for how many iterations? From I is equal to 0 to less than 10 means 10 iterations, and this scanf statement is executed for so many times. So, every time this is called, you read an integer and store the value to the appropriate index of the array, because the first iteration of the for loop, the index value would be 0, x of 0. So, first iteration, you're reading an integer from the keyboard and storing it at the memory location x of 0, and the second iteration, x value I value gets incremented to by 1, and it will be 1, and the second value, integer value which you are reading from the keyboard, will be stored at x of 1 index. So, this is how an array can be initialized at the runtime. Now, I have an example on the one-dimensional array. Okay. So, this is easy. So, which is based on the examples and the explanation what I told you people till now. I have declared an array of size 5. Enter the number of numbers to store them in the array. How many numbers I am reading? 0 to 4. 5 numbers I am reading. I'm dynamically. So, I am reading or initializing the array at the time of runtime. So, I am not done the initialization of the array at the time of declaration. Instead, I am initializing the elements of the array at the time of execution. Now, I am printing the same. So, I am reading here and then I am printing. Elements in the array are, so since even while you are printing, you require a for loop, because you got to print all the elements which are there in the array. So, running again one more for loop, I is equal to 0 to I less than 5, I plus plus, elements stored at, so I am just printing in the form of an array itself. So, printing it like this, a of 0. Okay. So, initially first iteration of the I value in the first iteration of the for loop will be 0. So, this is the print list and this is the format specifier, a of %d. This is the placeholder for this variable in the print list. So, this first %d is the placeholder for the first variable in the print list. So, it is in this order itself. Now, I value goes here, that is a of 0 is equal to array of I. Array of I is the first element gets printed here, and this second %d is the integer placeholder for the second variable in the print list. So, now you are reading dynamically or and initializing the array at runtime and printing all the elements of the array here, and then finally you are making a call to get a character. So, because I want so once this executes, I want to display the output on the screen. Sometimes when you want to display the output on the screen, so you got to use this get ch. When you hit any keys from the keyboard, you can see the output on the screen. Okay. So, and the sample running execution on this. So, enter 5 elements in the array. So, the prompting message. So, these are what I am reading. See, when I am entering all 23 and space is the delimiter here. So, this is taken as one integer and this is taken as another integer. This is one more, this is another, this is another. This is read and stored into a of 0. Oh, sorry, mistake here. So, these are not all zeros, sorry. Let me take a pen and update it. So, this is 0, but this is not 0, this is 1, and this is at the index 2, and this is at the index 3, and this is at the index 4. This is how they get stored. Next. So till now you understood 1D array, one dimensional arrays. Next is 2-dimensional arrays. So this 2D array is the simplest form of multi-dimensional array. And when I say 2D, so it's same syntax. Syntax remains the same. So you got to specify the type even for the 2D array also. So what type of elements you are going to store inside the 2D array? Because again 2D array is also an homogeneous array. It can't be an heterogeneous. You cannot have elements of dissimilar type. So they can be of only the same type or homogeneous type. Then give the name of the array, and then you have X and Y. So two subscripts are here. So if there is only one subscript, it is a single dimensional array. If there are two subscripts, it is a 2-dimensional array. So where type can be any valid C data type, and array name will be a valid C identifier. So this name is a valid C identifier. Okay. So that means this name, again it is framed by using all the rules which you have to follow for declaring the variable. 2-dimensional array can be considered as a table. So that's the reason it looks like a table which will have X number of rows and Y number of columns. Okay. So this is all. So these are the rows and these are the columns, something like this. And this is the element which is stored at 0th row and 0th column. One second. Discard here and let me check. Okay. So many of them are in participants. Okay, one second. I'll just make few of them and as attendees, because 13 of them are there as presenter. So for a while. Just a second. Then 9 more. I'll just finish it, because it will be a problem for me while taking the attendance. Well, when I download, see, if you have you people in the attendee list, it will be easy for me to mark the attendance. Make an attendee, yeah. Make an attendee. Make an attendee. Yeah, there are 4 more students. Let me finish it. And the last one. Okay. Okay. So now the first element in the 2D array is stored at 0, 0. Okay. A of 0, 0. So since you have 2 subscripts here, so the position of an element within the 2D array is defined using both the subscripts, F00. So this says the row number and this is the column number. So the first subscript says the row number and the second subscript says the column number. And similarly, if I take this, row 0, column 1 element. This is row 0, column 1. I hope all of you can see this. and then row 0, column 2, row 0, column 3, and similarly. When I go to row 1, sorry, again there is a mistake. So this is row 1, row 1, row 1, column 2, row 1, column 3, and this is row 2, sorry, this is column 0, column 1, column 2, that's fine. Row 2, column 0, row 2, column 1, row 2, column 2, and then row 2, column 3. Yeah, is it clear?
Yes, sir.
Yeah. Next. Now, in a 2D array, if you want to identify or locate an element, you got to make use of both the subscripts. Say row script, subscript also, and the column subscript also. So now we'll discuss how do we initialize a two-dimensional array. And again, this 2D array can also be initialized at the time of compilation or at the time of execution, or at the time of compilation or at the time of declaration. First, we'll try to understand how to initialize a two-dimensional array at the time of declaration or compile time. So this is how you can do it. So int a of 3, 4 is equal to, when it was a single dimensional array, you wrote it as int a of 3 is equal to open curly braces, and you wrote all the elements separated by commas, and you close the curly braces. So because it was 1D, so now it is not one dimensional, it is two dimensional. So it has rows and columns. So this is how you got to do. Now this, when you look into the subscript, it says 3 rows and 4 columns. 3 rows and 4 columns. This is first row, this is second row, this is third row, and this is column 1, 2, 3, 4. In each of these, you should have 4 elements. So row 1 and 4 elements, 0, 1, 2, 3. So this elements goes to the first row, and this element goes to the second row of the 2D matrix, and this element goes to the third element of the third row of the two-dimensional array. Okay, and similarly, there is one way of initializing. You can also do it like this. Here I have written it. This is also fine, and if otherwise, you can also do it like this. So this will be taken as the first element, second element, third element, and fourth element. Since the second subscript is 4, it will stop here, and this will be taken as the first element of the second row till here and again. So from here again it is, yeah. So 0, 1, 2, 3. This is the last element of the first row. This is the first element of the second row, and 8 is the first element of the third row. So you can do both the ways. So now, accessing the 2D array element, say I want to get the second row, third column element. So this is how I got to specify it. A of 2, 3. Second row, third column. Element is fetched and it is assigned to the variable value. Okay. The above statement will take the fourth element from the third row of the array. So here, fourth element. This element is taken and it is assigned to the variable int. Okay, I think we'll stop here. We'll continue in the next class. Next class, I'll be completing this arrays and then we'll start the structures. So probably I take one more class, 1 or 1.5 hours to complete the structures and pointers in depth, and then we will be starting with the data structures. So hope you people understood whatever I covered in the today's session. If you have any queries, you can discuss with me. If you have anything to ask, please do ask. Any queries?
No, sir.
Okay. Don't leave the meeting until I download the attendance list. Yeah, got downloaded. Okay, thank you.
Thank you, sir.
Yeah, thank you.